Okay, for more practice, we're going to do another example. We want to know what the normal force is on this, what's the force the hill has to provide to keep this truck sitting on it. The truck is sitting up here, and it's got a weight. The weight is the mass times gravity. So we're going to get the weight of this, and that's going to be the 2,000 times 9.8, which is 19,600 newtons. I want to know how much of that weight is sticking this to the hill, because some part of this is going to also be dragging this back down the hill, because it can't be pulled into it. It's going to be broken into two vectors. What looks like the y part, because it's up and down, which we should get used to thinking like that, is really going to be, instead of, it's normally associated, the up and down part, with sine, but on a ramp everything gets switched. So if this is 7 degrees, we're going to take this, and that's because the way the complementary angles work, it's not this angle you're really supposed to be taking the sine of, it's the one that's up here. But if we just learn to flip them when they're on here, then you can use that as your angle, and that still keeps in the rule that we've always used. Angles always get measured from the positive x-axis here. So if I say the force perpendicular times the cosine, this time, because we've taken the other, we got to take this time to a vector go first. It's the weight times the cosine of 7 degrees. When you do that, that force perpendicular is 19,500. So most of the weight is being supported by the hill. Only a little bit of force at this angle is actually pulling this down that hill. So if that's the force perpendicular, then we know, because they're opposites and these are the only two forces working in this direction, that the normal must be equal and opposite of that, 19,500 newtons, okay, and in the opposite directions. Don't get the vector of n, the normal, confused with the unit. So good job with that.